Welcome to the Deep Dive. Today we're getting into The Second Machine Age. It's by Erik Brynjolfsson and Andrew McAfee.
That's right.
Our goal here, our mission really, is to unpack it for you. We want to find the core ideas, the stuff you need to know, and importantly, what you can actually do with this knowledge.
Yeah, make it practical.
Exactly. There's a great quote they use early on from Licklider, I think. Technology is a gift of God.
Yeah.
Something like afterlife, maybe the greatest gift.
Mother of civilizations, of arts, and of sciences. Yeah, it sets a pretty grand stage, doesn't it?
It really does. So let's dive in and see what this second machine age is all about.
Okay. So Brynjolfsson and McAfee basically give us this framework for understanding, well, just how fast everything seems to be changing.
Right.
We'll look at how technology's progress is exponential, digital, and combinatorial. Those are the key drivers.
Okay.
And then we'll get into the effects, on the economy, jobs, inequalities, the bounty and the spread, as they call it.
Bounty and spread. Got it.
Yeah. And crucially, what we, individuals and maybe society can do to adapt.
Okay, sounds good.
Yeah.
So that first point, the pace of change, it really does feel faster now. The book mentions looking way back, like 14,000 BCE.
Yeah, Ian Morris's work, trying to track progress over millennia.
It makes you think, what was the big deal back then? Domesticating animals?
Right, or the invention of writing. These massive shifts, but spread out over huge timescales.
Compared to now, where it feels like things change year to year almost.
Exactly. And they argue that this current era, driven by digitization, isn't just another step up. It's fundamentally different, a real bend in the curve.
Because of those three things you mentioned. Exponential, digital.
Exponential, digital, and combinatorial. Those are the engines. Let's take them one by one.
All right. Exponential first. We hear about Moore's Law a lot. Computers getting faster, doubling. What's the significance now?
Well, Moore's Law, the observation that chip power doubles roughly every 18 months or so while costs drop, it's been incredibly persistent. And it's not just about faster gaming PCs. It affects everything digital. Storage, sensors, network speeds. The power of sustained exponential growth is, well, it's hard to grasp intuitively.
They use that chessboard story, right?
Yes, perfect analogy. The inventor asks the emperor for rice. 1 grain on the first square, 2 on the second, 4 on the third, doubling each time.
Seems like nothing at first.
Exactly. The emperor thinks it's a tiny reward. Even halfway across the board, on square 32, it's a large amount, maybe a field's worth of rice, but manageable.
Okay.
But then you get to the second half of the chessboard, the numbers become astronomical, ridiculously large, more rice than exists in the world by far.
Wow.
And the point is, we're now in that second half of the chessboard with digital technology. The progress feels so fast because the numbers are finally getting huge. We've been doubling for decades, and now the results are dramatic.
That makes sense. So it's not just our perception. The pace has fundamentally shifted.
Yes. And it wasn't just luck. The book mentions brilliant tinkering. Engineers kept finding clever ways around physical limits.
Like what?
Well, when they couldn't physically shrink transistors much more, they started stacking them, making 3D chips. Or in fiber optics, using different colors of light wavelength division multiplexing to send way more data down the same fiber. Constant innovation kept the exponential curve going.
Okay, so that's the exponential engine. Powerful doubling.
Yeah.
What about digitization? How does that fit in?
Digitization is the process of turning things, information, sounds, images, sensor readings, into digital bits, ones and zeros. Once something is digitized, it becomes subject to that exponential improvement we just talked about. Its data can be processed, stored, and transmitted using ever more powerful digital tools.
And it changes the economics too, right?
Massively. Think about it. Making the first copy of a digital movie or song might be expensive, but every subsequent copy is basically free.
Yeah, just click copy.
Exactly. Free, perfect, and instant reproduction. That's revolutionary. It's why services like Google Translate can exist. Well, Google Translate doesn't really understand language like a human does. It works by statistically analyzing enormous amounts of digitized textbooks, websites, documents that have already been translated.
Pattern matching on a huge scale.
Precisely. Something only possible because so much text has been digitized and is cheaply accessible. And the sheer amount of data being created now is staggering.
I bet. Exabytes, zettabytes.
Zettabytes, trillions of gigabytes. It comes from everywhere. Internet traffic, sensors and phones, social media posts, scientific instruments.
And this data itself is a resource.
A huge one. The book mentions culturomics, analyzing millions of digitized barks to track word usage, historical trends, even how fame works. You can ask questions about history and culture that were impossible before.
That's fascinating. It makes sense why Hal Varian at Google said statisticians have this sexy job now.
Absolutely. Making sense of all this data, extracting insights, that's a critical skill.
Okay, so exponential power applied to digitized information. What's the third leg? Combinatorial innovation.
Right. This is about how digital technologies make it easier to combine and recombine existing ideas or tools to create something new. Think of digital tools like Lego bricks.
Okay.
There are more bricks available now than ever before, and they're easier to connect in novel ways. The economist Paul Romer called things that help us generate more ideas meta-ideas, and digital networks are a prime example.
Can you give an example of this recombination?
Instagram is a great one. Mobile phone cameras existed. Digital photo filters existed. Instagram just combined them in a simple, appealing way on a network.
And boom, billion-dollar company from a simple combination.
Exactly. It shows you don't always need a massive breakthrough. Sometimes cleverly combining existing digital pieces is enough to create huge value.
But with so many digital Lego bricks now, how do you figure out which combinations will actually work or be valuable? Must be overwhelming.
It is a challenge. The number of potential combinations explodes. That's where things like crowdsourcing and diverse perspectives become really important.
How does that help?
Platforms like Incentive or Kaggle post tough problems, maybe scientific or data challenges. People from all sorts of backgrounds, even outside the specific field, can propose solutions. Often someone with a different perspective, maybe from a completely unrelated field, sees a connection or an approach the specialist missed. They bring a different set of mental Lego bricks to combine.
So harnessing collective intelligence to find those winning combinations.
Exactly. Or look at Quirky, which used the crowd not just for ideas, but also for filtering which product ideas were worth pursuing. Or Afanova, using algorithms and crowdsourcing to figure out the best combination of features for a new product, like they did for Carlsberg beer.
Okay, I see. So these three forces, exponential, digital, combinatorial, they're working together to create what the book calls the computing bounty.
Precisely. The bounty is this explosion in the volume, variety, and quality of stuff available to us, often at lower costs or even free.
What are some examples of this bounty?
Oh, there are tons. Things that were science fiction just a decade or two ago. Self-driving cars are on the roads. Yeah.
AI beat the world champion at Go and Jeopardy. Robots are becoming way more capable in factories and warehouses. 3D printing lets us create custom objects.
It's pretty amazing.
Think about medicine, too. Devices like Orcam helping the visually impaired read text in the real world. Cochlear implants restoring hearing. Even brain-computer interfaces allowing people to control wheelchairs with their thoughts.
Wow. And AI in diagnosis. You mentioned Watson earlier.
Yeah, systems like IBM's Watson can ingest and analyze vast amounts of medical literature, potentially helping doctors make better diagnoses or choose treatments. A human doctor simply can't keep up with the explosion of medical research published every week. AI can help synthesize that.
So the potential seems huge. The book argues the limitation isn't imagination anymore.
Right. It's more about access. For a long time, a huge portion of the world's population simply didn't have access to the world's knowledge or the tools to contribute.
But that's changing fast with mobile phones, isn't it? Dramatically fast. Billions of people, especially in developing countries, have leapfrogged straight to mobile, many now with smartphones. They're joining the global conversation, accessing information, creating content, participating in the digital economy.
Bringing billions more minds into this combinatorial innovation process.
Exactly. And access to computing power itself is becoming democratized through the cloud. Carl Bass called it infinite computing. You don't need a supercomputer in your basement anymore.
Okay, so this bounty sounds fantastic. More stuff, better stuff, often cheaper. But then the book introduces the spread. What's the downside here?
The spread is the flip side. It refers to the growing inequality in economic outcomes in wages, wealth, opportunities.
How so?
For much of the 20th century, as productivity rose, as the economic pie got bigger wages, for typical workers generally rose along with it, most people shared in the prosperity. But starting around the 1980s and accelerating since 2000, that link seems to have weakened or even broken in many developed countries. Productivity keeps going up thanks to technology, but the median wage of the person right in the middle has stagnated or even fallen.
So the pie is bigger, but the average person isn't getting a bigger slice, or even their slice is shrinking.
For many, yes, the gains are flowing disproportionately to certain groups.
Who are the winners in this scenario?
The book argues technology favors people with the right kind of capital. That means owners of financial capital, but also people with valuable human capital-specific skills, creativity, high levels of education that complement the new technologies.
Okay.
And then there are the superstars, people who can leverage technology to reach a massive audience and capture a huge share of the market in their field.
And the losers, or those left behind.
It tends to be people whose skills are easily automated or made redundant by technology. Often, these are jobs involving routine tasks, whether manual or cognitive. This is sometimes called skill-biased technical change. Technology increases demand for high-skill workers and decreases demand for middle or low-skill routine workers.
It's not just robots taking assembly line jobs then.
No, it affects cognitive work too. Think about tax preparation software replacing bookkeepers or automated systems handling customer service inquiries. And there's also organizational co-invention.
What's that?
It means companies don't just adopt new tech, they reorganize how they work to take advantage of it. This often requires different skills, maybe fewer middle managers, more data analysts, pushing decisions down or up the chain. These changes often further favor highly skilled workers.
And we see this in broader economic numbers.
Yes, the data shows labor's share of GDP declining in many countries, while the share going to corporate profits has been rising.
Let's talk more about these superstars. How does technology create these winner-take-all or winner-take-most markets?
Several factors. One is the near-zero marginal cost of digital goods we talked about. Once you've made the software or the digital song, distributing it to one more person costs almost nothing.
Right.
Combine that with global digital networks, and the best product or service can potentially capture the entire global market very quickly. Think Intuit's TurboTax dominating DIY tax software, or a single successful musician or YouTuber reaching billions of people directly, something unimaginable before. The reach is immense.
So small differences in talent or quality can lead to massive differences in rewards.
Exactly. Plus, digital tools allow for better monitoring and management, which increases the impact and thus the value of top executives or key talent. The quote they use is something like, "When a sergeant makes a mistake, only the platoon suffers, but when a general makes a mistake, the whole army suffers." The scale magnifies the importance of getting the best leader.
Network effects play a role too, right?
Yeah, definitely. Platforms like Facebook or Windows become more valuable the more people use them, creating a natural tendency towards dominance. Globalization and reduced trade barriers also help create larger markets where superstars can thrive.
Is there anything pushing back against this?
Well, the book mentions the long tail. The internet makes it easier to find niche products. So while superstars dominate the hits, there is more variety available overall. But the dominant force seems to be towards concentration of rewards.
Okay, so we have this incredible bounty, more wealth, amazing new tools, but also this growing spread, this inequality. This sounds like it has huge implications for jobs and society.
It really does. It brings up old debates about technological unemployment. People like Keynes worried about it back in the 1930s.
Technological unemployment jobs disappearing due to automation faster than new jobs are created.
Right. Historically, technology has always created more jobs than it destroyed in the long run, but the transition can be painful and disruptive for many. The question now is this time different because the technology is cognitive as well as physical?
Can machines start replacing brain work as well as muscle work?
That's the concern. The book uses a thought experiment. What if we invent perfect androids that can do almost any human job cheaper? What happens to wages?
Wages would plummet for most people, I imagine. Unless you own the android.
Exactly. Or unless you have skills the androids can't replicate. It illustrates how competition with increasingly capable machines can depress wages, even if the overall economy is growing. Add in global competition, competing with lower wage workers elsewhere via technology, and the pressure on wages for routine work becomes intense.
So what's the takeaway for individuals? How do we navigate this? The book talks about learning to race with machines, not against them.
That's the key idea. Trying to do the same routine tasks as computers, only slower or less accurately, is a losing game. The goal is to focus on skills and abilities where humans still have an edge or where we can effectively partner with technology.
But predicting those skills is hard, isn't it?
Very hard. The authors mention how earlier predictions about what computers couldn't do have often proven wrong, but they point to freestyle chess as a model.
Freestyle chess.
Yeah, where teams of humans plus computers compete. It turns out the best players aren't necessarily the strongest grandmasters or the fastest computers alone. It's teams that are good at leveraging the computer's tactical brute force while providing strategic guidance and creativity. Human-machine collaboration.
So complementing the machine's strengths, what does that mean for education? The old 3 R's, reading, writing, arithmetic, might not be enough.
Probably not. The focus needs to shift towards critical thinking, creativity, complex communication, collaboration, problem-solving skills that are harder to automate. The book critiques education systems built for the industrial era, focused on rote learning.
It mentions things like Montessori or SLE's, self-organized learning environments.
Yes, approaches that emphasize curiosity, self-direction, project-based learning. Unfortunately, some research suggests colleges aren't always doing a great job at improving critical thinking skills.
So develop skills computers are bad at. What are those currently?
Well, despite progress, computers still struggle with interacting with the messy, unpredictable physical world, fine motor skills, dexterity, navigating novel environments. Think plumbers, electricians, nurses, gardeners. Moravec's paradox: easy for humans, hard for robots.
Like folding laundry. I saw that robot video.
Exactly. Took it forever. Also, complex interpersonal skills, empathy, leadership, teamwork, nurturing these remain profoundly human domains. For now.
For now. That's the catch, isn't it? The goalposts keep moving.
They do. So the other key is adaptability and lifelong learning. You can't just learn one skill and expect it to last your whole career. You have to constantly update and learn new things, be flexible, focus on creativity, pattern recognition, complex communication, but know that AI is making inroads even there.
So the individual advice is collaborate with machines, develop uniquely human skills like creativity and complex communication, be adaptable, and never stop learning.
That's a good summary of it.
Okay, what about the bigger picture? What policy recommendations does the book make to help society manage the bounty and the spread?
They offer quite a few, aimed at boosting the bounty and mitigating the spread. A big one is investing in human capital.
Education again.
Yes, but reforming it. Focus on those future-proof skills. And leverage technology itself, like MOOCs, online learning to broaden access and maybe even personalize education. Use data to see what works.
Makes sense. What else?
Fostering entrepreneurship. Startups are historically where most net new jobs come from, so make it easier to start and grow businesses.
Okay.
Improve matching people to jobs. Use technology to create better platforms for job seekers and employers. Maybe even use prizes to incentivize better matching algorithms. Support companies using analytics for smarter hiring.
Like using data to find good fits.
Exactly. Then support basic research. You never know where the next big breakthrough will come from, so funding fundamental science is crucial.
Infrastructure.
Absolutely. Not just roads and bridges, but digital infrastructure like universal broadband. Essential for participation in the modern economy.
What about immigration?
They argue for reforming immigration to make it easier to attract and retain high-skilled talent from around the world. Immigrants have historically been huge drivers of innovation and entrepreneurship in places like the U.S.
These seem like ways to boost the bounty. What about tackling the spread, the inequality?
That's tougher. They suggest considering taxes on things that are relatively inelastic, like land, or maybe higher taxes on the very top earners. The superstars arguing research suggests it wouldn't necessarily kill incentives.
Okay. Any more radical ideas?
They discuss experimenting with a universal basic income, UBI, or a negative income tax.
UBI. Giving everyone a regular sum of money.
Yeah, or a negative income tax, which tops up incomes below a certain level. The idea is to provide a basic safety net, decoupling income from traditional work, which might become scarcer or less well paid for many due to automation. They note it's an idea with historical support from across the political spectrum. Even Nixon proposed something similar.
That's a big one.
It is. Also, updating existing social safety nets, Social Security, healthcare, thinking about how they're funded if machines are replacing labor, and encouraging the peer-to-peer or gig economy, finding ways it can supplement incomes.
So a mix of boosting innovation and providing safety nets or new ways to distribute the gains.
That seems to be the approach. Investing in people, encouraging new businesses, supporting research, fixing infrastructure, and then finding ways, whether through tax policy or direct support, to ensure the benefits are shared more broadly.
Looking even further ahead, does the book touch on longer-term risks or the singularity idea.
They acknowledge potential downsides, cybersecurity risks, technology empowering bad actors, privacy concerns in a totally digitized world. They mention the singularity briefly, the idea of AI surpassing human intelligence, but their focus is really on the next decade or two, the changes we're already grappling with.
And the main message there.
That the future isn't technologically determined. We have choices. The technologies are powerful tools, but how we use them, how we structure our society and economy around them, that's up to us. They end optimistically, suggesting that if machines handle more work, maybe humans can focus on exploration, creativity, community, deeper forms of satisfaction.
Unleashing human potential, essentially.
That's the promise of the second machine age, if we manage it well.
Okay, let's try and wrap this up then. Key takeaways. Technology is advancing at this incredible, accelerating pace, driven by the exponential digital and combinatorial forces.
Right, creating this amazing bounty of goods, services, and capabilities.
But also leading to a spread, growing inequality in income and opportunity, favoring skills that complement technology, and the rise of superstars.
Yeah, a real decoupling for many workers.
So for us, the advice is learn to race with machines. Focus on creativity, complex communication, critical thinking, and lifelong learning. Adaptability is key.
Couldn't have said it better.
And on a societal level, we need policies that invest in people, foster innovation and entrepreneurship, build infrastructure, and find ways to share the prosperity more widely, perhaps through rethinking safety nets or taxes.
It's about shaping the technology's impact, not just letting it happen.
It's a lot to think about. So, the final thought for you listening, how will you adapt? What specific skill, what area of knowledge are you going to explore further after hearing this? How will you race with the machines in your own life?
It's a question we all need to ask ourselves.
Definitely worth digging deeper into the book if this sparked your interest. Thanks for joining us on this deep dive into the second machine age.